Hello again, Hank.
Hello.
So I often can't make this call, so it's rather nice to be able to do for a change.
Yeah, I'm in a home office place right now, so I've got the time finally.
Good.
Hey everybody, how are y'all today?
Doing okay, thank you. I've added my name to the attendee list like a good attendee.
Being a model citizen, thank you.
I'll try to set a good example, otherwise I'll get in trouble myself. So.
I'm today's chair. I'm going to wait another minute or so for any last minute stragglers. We have Mike Stoons here, who is
Hey, Greg.
Point to.
Hey, everyone.
Yeah, hey.
I'm putting a link to the agenda and stuff in
Oh, is that the
chat.
link to sign in? To put your name on if you want.
Yep.
I guess while we're waiting the last 30, 60 seconds, does anybody have any additional agenda they wanted to put into today's discussion?
There is one thing, a minor, I think, but I'll add it here. So we've been asked by one of the other groups, the TWI group in Trustworthy Identity, Trusted Work Identity, I mean, to come up with a definition, I think, really. I mean, it probably needs to go through the TAC as well, but we're a good place to start, which is when we're talking about the different parts of the things that we measure, basically, and attest. We kind of, I think, generally know what we mean by a workload measurement. workload attestation. But what do we call the other bit? Do we call it system? Do we call it platform? And I think having a shared definition, shared name, well, at least shared naming, even if we don't have a definition to start with, will be helpful. I was planning to write a blog article on this, just started the other day and suddenly realized I wasn't sure which to call it. So having something that we think we should standardize would, I think, be helpful. So let's do that if we can.
So are you suggesting or requesting like an on-the-fly conversation for a few minutes today about what folks would think about, or what folks use for naming or would suggest for naming? Or are you thinking about discussing a process to produce like some sort of, a written result? Or
I think we should see if we can come up with a consensus as to whether we call it system or platform to start with, and then we should think about a definition or a set of definitions that we could write down in the longer term. But at least knowing what we're discussing and what we call it is always a good place to start. Does that make sense?
Mm-hmm. Mm-hmm. I think our agenda today is perhaps not super packed. So I think from a timing perspective, I think we'd be fine if we gave 5 or 10 minutes for the topic you just proposed. But I would want to time box it if it starts going longer to ensure we have ample time.
Of course. No, I think this is a starting point. I wasn't expecting us necessarily to make a decision today, but at least we can do it here. Maybe have a discussion on the Slack as well, whatever. But,
all right. So do you want to do that first, or you want to do that at the end?
We've got Mike here. We've invited him. We should give him the time slot first. I don't think my thing is urgent, but
okay. Sounds good.
With sure, sounds good.
So yeah, so the first topic today is basically an opportunity for folks to ask any remaining questions or questions that have come up since the last discussion. 2 weeks ago, Mike Stunes from Microsoft presented a presentation on how VTPMs work in Azure and how they're bound to the platform, the hosting platform, for example, CivSMP TE technology. And there was a handful of questions discussed during that hour. And I think there was some unfinished questions and perhaps some new ones. So with that, I'll turn it over to Mike, who's graciously accepted to come back and field some questions and hopefully maybe give us a quick 5-minute refresher on what he presented last couple weeks ago.
Sure.
So
okay, let's see if I okay, do you see the slides?
Yeah, I see them.
Okay, excellent. So thanks, Greg. It's good to be back. Yeah, so a couple of weeks ago we talked about binding CVM evidence and VTPM evidence in the Azure platform, and I'll just kind of run through the material that I presented last time here. For the context, we're talking about, we have the ability to sign state or arbitrary data from a VTPM using a key that lives in the TPM. We provision keys into the VTPM on Azure, the Azure platform. And so we're wondering, how can we use this binding to prove, say that, information that we're signing is actually living in a CVM, the VTPM lives in a confidential VM, and how do we prove things about the confidential VM and bind these things together? A little bit of context is, in our platform, we have virtual machines that use our virtual secure mode technology, which gives us privilege layers inside of the VM that we can use to, say, implement a VTPM in a high privilege environment that's protected from the guest OS, but still inside of the confidential VM boundary. So we can also protect it from the host. And then also the host provides an encrypted storage for VTPM secrets and that kind of thing that live inside of the VM. So we walked through, I'll just skip through the whole build here. There we go. We walked through the process of binding the attestation information. We have a attestation key that lives inside of the TPM and can be used to sign TPM quotes. The TPM implementation is provided by our OpenHCL host compatibility layer, which is the first thing that's loaded into the confidential VM when it boots. And so the HCL is measured into the VM's attestation report at boot. That measurement is put into an endorsement, which is signed by Microsoft and published so it can be validated. And furthermore, the keys that are used to sign TPM quotes and TPM state is also put into the attestation report as extra data. And the attestation report, of course, is signed by the CPU platform keys. So that including the TPM key material in the attestation report is what provides the binding between the TPM evidence and confidential VM evidence. And the measurement of the HCL, which provides the VTPM implementation, is what provides the guarantee that the TPM is, well implemented and well behaved, and so on. Mohammed?
Yeah, hello. I just to be on the same page. So what you are saying here is that so first this signed by AK is the VTPM AK versus the TE AK, right? And
correct.
Second thing that this will actually contain the PCR values for the guest OS.
Yes.
And the binding between the two is actually based on this, let's call this attestation key of VTPM. This attestation key public part being put into the R data field of, let's say I'm talking about Intel TDX field. So it will be put inside the R data field of Intel TDX in TDX code. Is this correct?
I'm a little hazy on the details of like exactly how the attestation report is structured, but I think that's the idea, yes.
Okay, okay, so without any details, maybe one level high. So you put the public key of VTPM, let's say the VTPM attestation key public part into the TEE evidence, right? So
yes, yep.
Okay, sounds good. Thanks.
Yep, correct. Mark?
And I think if you, I'm sorry to jump in, but if you jump in just one more level of detail, it's not the key. There's a hash of a structure, in our case, a JSON string that contains a bunch of fields, including the public key of the AK. So the report has a hash, and the hash is a JSON object with a bunch of claims, and one of the claims is the public key for AK.
Okay, so is there a specification available which tells exactly what goes into the user data field of TDX? Like Greg, what the fields that you are mentioning, like other than pub AK, what exactly goes into that? Is there a clear specification on that?
I believe so. Let me.
Because the problem I see is that if it no longer allows, or at least in my understanding, so it no longer allows the user to put in any arbitrary data. And
let's see, I think this is the link.
Might be what Greg was getting at.
I mean, you can always add user data to, just keep hashing, right? Or am I missing something? I don't know.
So you're yeah, go ahead, Mike.
There's detail here that I can will share in subsequent slides. So should we just forge ahead for now and then see if that answers your questions? Okay.
Yeah, sure. Thanks.
Yep. Mark, Novak, did you have something?
Yeah, I do have one question. I just apologize if it was mentioned and I missed it. So how is the attestation key itself, which is an asymmetric key, procured, and how is it protected at rest? Because ultimately the concern is
Right.
You know, if the hosting environment knows what it is, or
Yeah.
if you know, it's not protected at rest, then
Yeah.
well,
Right. So yeah, that's a good question. So let me jump back a slide here. So the key those keys are actually, they're generated inside of the TCB. And I don't remember, there's some technical detail here that I just don't remember offhand. It's either inside of OpenHCL during provisioning, or it's done by another Azure service that we consider part of the TCB. But the host OS, like the host that's actually running the VM, never sees that. It's
yeah. I'm more
I
worried about things
agree.
like the VM image may contain it, or if it is going to, it's like if you're migrating the workload, live
Right.
migrating, then
Yeah.
it at some point in time is going to be put on the wire and
Sure.
picked up by the target host. Well, maybe you can come back with that. I don't want to hold up the
Sure.
conversation, but that's sort
Yeah.
of, that's
Well,
your root of trust. So.
Yeah, that's a great question. Let's come back to that at the end, because that's interesting. Okay, so we'll just, so this was the whole chain of trust diagram. I put a link in the chat that has some of the technical details, and I think from that link, I actually found this diagram, which is basically the same thing I just showed. So there's an Azure, well, okay, so there's the hardware vendor that certifies everything up to the hardware attestation report, which includes the attestation key out of the VTPM. And then there's also, this is not really part of the binding, but it is an Azure CA that examines the attestation report and signs a certificate over the attestation key out of the VTPM. And the guarantee that provides is that this is a compliant Azure confidential VM, which means a bunch of things, including the OpenHCL image is one that we have blessed as an official Azure image. And I think other security policies are included in there, like, you know, you don't have debug enabled on the confidential VM and things like that. So let's see. Okay, so for back to the technical details here. We have sort of augmented our VTPM implementation with a mechanism for guest software to access attestation reports using interfaces provided by the TPM. So the TPM gives you, ability to access NVRAM indexes, which is just key value storage, essentially. So what we have done is we put an attestation report with some other stuff around it in one of those TPM indexes, and then guest software can just read it and get the platform attestation report. So this is a link to our code for OpenHCL with the structure of the information that we put in that NVRAM index. There's also, let's see. Oh, there we go. Here's an example of, Greg mentioned we have this JSON document and we put a hash of that document in the attestation report as the extra data. So this is what you would see in that JSON document. You have, for starters, you have the AK and EK from the VTPM public parts. There's some extra information about the configuration of the VM itself, including whether secure boot and VTPM are enabled. And then finally, we provide an extra user data field of our own. So guest software can write any data that it wants to another NVRAM index in the VTPM. And when the guest does that, then we will go get an attestation report with that data included in this document, and then the hash of this document put in the platform attestation report. Let's see, I mentioned there's an AK certificate, which is signed by the Azure CA, which is also signed over the AK in the virtual TPM. And finally, I left off with some technical resources that I thought might be of interest for folks here. So I think all of that should be in the slides, and I think Greg put the slides in the appropriate place for this group, so they should be available to you. So that was a quick recap. So yeah, let's dive into it.
I think I see Osama has his hand up, and I don't think, as I heard it, I don't think Mark's question about how the persisted AK and EK for the VTPM is handled, right? So
Yeah, okay,
specifically
so
like when
let's-
things are migrated. So
Yeah. Do you mind if we take the VTPM key question from Mark and then
yeah,
take
that works fine from an ordering perspective.
great.
He asked the question already.
Yeah. Yep. Okay. So I'll go back to this diagram here. So the private keys are generated inside of the TCB somewhere when the VM is provisioned. So they're not, I guess they're not exactly part of the VM image when you create a new VM. They're just generated anew each time you provision the VM. And it's the persistent state of the VTPM is stored in this file called the VMGS file, which is virtual machine guest state. And from the host's point of view, this just looks like another virtual disk that's attached to the virtual machine, but its contents are encrypted with a key that is not known to the host. And there's an extra service off to the side, which we spent a bunch of time talking about a couple of weeks ago, called Azure Key Vault. So when you create a VM, you can provision a key in Key Vault, and that is actually used as the encryption key for this VMGS file. When you power on your confidential VM, we load the OpenHCL, and then OpenHCL does an attestation process with the Microsoft Azure Attestation Service, which will, I'll start drawing here because, let's see, pen. Okay, so we have, over here we have Microsoft Azure Attestation. So we power on the VM, OpenHCL loads, and it presents its attestation report and things to MAA, which verifies the OpenHCL image, verifies the configuration of the VM and that sort of stuff, and then sends back a token, which OpenHCL can then present to the Key Vault service. This is Azure Key Vault here. So OpenHCL will present that token to Azure Key Vault, and it will get back the key that it can use to decrypt the VMGS file. So that's the basic flow that we use. So as for live migration, that's a good question. And I mean, the answer there is, I'm very hazy on the details here, but the answer there is the SEV S&P or the TDX platform provides mechanisms where we can migrate a confidential VM with the data, a secure channel set up between the two confidential platforms. And so the host is out of the loop on that, and all the VTPM state is migrated in that context. Greg?
Where's the code? What's the logic around? Because clearly, like the VMGS is specific to a particular VM, right?
Yes.
And there shouldn't be, right? VM1 shouldn't be able to decrypt VM2's VMGS. So where and how is that enforced?
That is a work in progress, and it's a flow that's going to be basically when we provision a new VM, it's going to. I'm getting echo. I'm getting echo from somebody who's unmuted. Okay, let's try that again. Okay, that's better. Thanks. There's a flow where when we provision the new VMGS state for a VM, it's going to be basically have an identity bound to it, and then the key release policy between MAA and Key Vault can like verify the binding and provenance of the VMGS file after it's provisioned. Like I said, that's kind of an active work in progress right now.
Where does that code live, like on this diagram?
That'll be in the provisioning service, which is not on the not in this diagram, and in I think that'll be in Key Vault as part of the key release policy.
Cool, thank you.
Yep.
I have a related question to what Greg just asked, and
Mhm.
also to the diagram that is there now. So when you, on the very first step, that the OpenHCL goes to Microsoft Azure Attestation, are
Mhm.
you saying that is the complete evidence of the whole VM, or what are the contents? Like, what is contained in that evidence that Microsoft Azure Attestation Service will check? Is that only of OpenHCL? Does that include guest OS, or what does that include?
Well, let's see. It includes OpenHCL and like its measurement, and also includes a set of claims about the configuration of the VM. So if I go back to this slide, I think this is like, this is the user data this is the user data that we hash and then put in the report. So like additional stuff it includes is like the VM configuration with runtime configuration of OpenHCL. In the future, there's work in progress for information about the provenance of the VMGS file and its identity. I don't know what there is about like information about the guest OS at that point. I guess I'm curious, like what other information would be of interest or of use in that context?
Right, I was trying to just understand the
Yeah.
first starting point. I don't necessarily mean that OS measurements should be there or should not be there. So
Yep.
that was not
Sure.
my intention, just to
Yeah.
clarify.
Yep.
And I think the user data field is only, let's say, one specific part of the whole thing.
Mm-hmm.
And
Yep.
like attestation report, like it's just one field. There are quite other claims that are also security relevant. But coming back to the first thing, so what I understand is in the first process, or in the first step of the process diagram, in the last diagram figure.
Yep.
So OpenHCL will generate an evidence, and that evidence will contain the user data field as you described on that slide. So that contains the VTPM public parts of the VTPM attestation key and endorsement key.
Yeah, actually, okay. Yeah, sorry, clarifying here. So we may do OpenHCL will send, I guess, different information, like different additional information bound to the attestation report at different times. So in this first part of the process, we actually, yeah, sorry, that was kind of a miss on my part there. We actually don't have the TPM private keys yet, because this is the process that we go to unlock the VMGS, which is where those private keys are stored. There are subsequent flows where, so like after we've unlocked the VMGS, then we can do things like provide that user data document that has the public keys embedded in it to guest software. There's also another flow that we go through to where I mentioned we have we have this certificate that's signed over the attestation key. So after we do the secure key release and unlock the VMGS and get the keys for the VTPM, then we can do another flow to get this certificate from the Azure CA. And it's like that process involves also sending an attestation report with additional data that includes the keys in it. But yeah, before we unlock the VMGS, we actually can't put the VTPM keys in the document because we don't have them yet.
Okay, so now that makes more sense to me. So
yeah,
if I understand correctly, there are at least 3 times the OpenHCL will generate an evidence. The first one, it will generate for without any keys, just the load time measurements, and it will send it over to Microsoft Azure Attestation. That will give it back some token saying that or checking that the configuration was correct and it will
Mhm.
not contain
Yep.
the keys which are on this slide, right? The attestation key
Correct.
and that's
Yeah.
not a part of the first phase of that
Right.
OpenHCL.
Yeah.
Now
So in
the
yep,
yeah,
just
yeah,
real quick, in phase
sure.
one, so in phase one, we don't have this, but we do have this. So like this is configuration information that was given to OpenHCL at the time the VM booted. And so this is part of the attestation, like the initial attestation.
Right, perfect. So
Yep.
now
Yep.
I'm on the same page. That makes sense.
Yep.
And with that, let's say it gets a token from Microsoft Azure Attestation,
Uh-huh.
and it sends it, meaning the OpenHCL, then sends that token over to the Azure Key Vault.
Mhm.
And Azure Key Vault, as on this slide now, will give it back the keys for the VTPM or somehow the keys with which it will decrypt the VMGS. Is this
Yep.
so the last step is a bit
Correct.
unclear to me. So is it like the keys to decrypt VMGS, or is it the keys for the VTPM, the attestation key and the endorsement key?
Key Vault will give back the key to decrypt VMGS. And the VMGS contents include the private keys for the VTPM.
Okay. So I think now the loop is kind of complete. So through this process from the VMGS, it will get the private key of private endorsement key, private attestation key, and now it has both keys. And with these keys, including these keys, with the new evidence now generated, it will go over to, it will generate the evidence which will be sent over. So that's maybe the phase 2.
Yep.
Okay. And the provisioning service that Greg was mentioning, so I couldn't catch up with that. Could you please repeat, like in the 2 phases that we have discussed, first for getting the keys from Microsoft Azure,
Yep.
and second for generating a complete evidence with attestation key public part, with endorsement key public part. Could you please repeat the thing that you said to Greg? I couldn't follow that. Where does that provisioning part lie? Or is the second, or is the first phase what you call as the provisioning part?
So the first phase where we go to Azure Attestation and then Azure Key Vault, that's the secure key release process. Let's see if I can, no, I can't type on the slide. Oh, well. So this process is secure key release. And then there's a second process that we go through, and then we'll say there's like a second process for getting the AK certificate. So that is, there's more attestation evidence. That's where we produce the attestation report that contains the keys and everything. And I don't remember the name of the service that goes out to, but there's some cloud service out here where we send an attestation report and we get back a certificate. There is I mentioned a provisioning service. The provisioning service is what I believe creates the initial contents of the VMGS file. And eventually, like I said, there's work in progress to kind of augment that with some provenance about the authenticity of the provisioning and to an OS disk. Detail on that because it wasn't as interesting from the attestation perspective, I guess. And I'm a little fuzzy. I'm personally a little fuzzy on the details of what goes on in the provisioning service.
Okay, so from a timing perspective, does this secure key release happen before this provisioning?
After. So when you want to create a new VM, we would first provision it, and that includes creating the VMGS file, creating the virtual disks, and so on. And then after that, we will schedule it to a host and then power it on. And when we power it on, we load OpenHCL, and then OpenHCL does the secure key release process. So the SKR happens at every VM boot, and the provisioning is just like when you create a new VM.
Okay, sounds good. Thanks.
Let's see. Mo? Mo, you have your hand up?
Like Mo's
You're
stuck with his
muted.
hand up. Oh.
Oh, sorry. Can you hear me?
Yeah.
Awesome. So yeah, I was just going to ask a question regarding this approach of the deep TPM attestation. Is it like the current way that it's currently been done in the V5 instances, or is it like something for the future for the V6? Because
Yeah, good question. In broad strokes, the process that I've described is current for both V5 and V6. Let's see, V6 VMs are using OpenHCL, V5 VMs are using a different implementation of the HCL.
I see, because we recently encountered actually some issues on the V6 compared to the V5, where the attestation on the V6 are being completely borked, like are broken.
Oh.
So I was wondering if you have changed the TPM attestation algorithms, because on two sides it's failing. One of them is failing on a comparison with the Intel PCCS, like the TCB values, where it's in particular the seam loader is being completely outdated on the V6 machines. And the second issue I'm encountering is with the VTPM attestation as well. Like I tried like to kind of hack it and enforce outdated values just to continue and see if it works. And then it failed on the TPM. It's not able to replay the event logs on the PCR value 11, which is, I think it's for the unified kernel plus the rest of the stuff that's being extended there. So I'm not sure if that's the case on V6, but V5s are still working perfectly fine. But the V6 are kind of broken at the moment. And the scary part is that recently Azure announced that V5s are completely going to be retired by September. So, so I was also wondering if you can, if you know, like by chance, what's the plan for the future for the V6?
Yeah, I don't know what I can tell you about future plans, but that's interesting. Could we follow up offline about the issues you have with V6?
Sure, definitely.
Yeah, that'd be great, because yeah, I want to make sure it works. Hank?
Yeah, hi, this is Hank. I might not have paid enough attention, but in the additional red diagram boxes, you put the cloud thingy in to get the AK cert for the VTPM. What are you sending to that cloud thingy again?
Attestation report that includes TPM public keys.
Okay, so it's basically, okay. Makes sense. These are not generated, right? So these are per VTPM, or was there a mechanism behind creating or issuing the AK certs?
I don't really know. It's kind of outside of my area.
Okay, no problem. But I understand.
That's a good follow up, though. Yeah.
Okay.
I'll see what I can find out. Let's see. There was a question I remember from last time about I think for virtual secure mode and the virtual trust levels. So I found a slide deck here from QEMU. I think Amazon was working on it, so I'll put that in the chat here for people to look at. Oops, wrong. Hold on. There, I'll put that in the chat for people because it's probably of interest. I don't know what the status of that project is. I just know it was going on.
Thanks, Mike.
Let's see. I'll just go through the chat here as I see interesting questions. Let's see. Let's see. Mo asked about sealing keys. That's a good question. I think there's some work in progress for us to support hardware sealing, but the problem is then that doesn't play nice with cloud scheduling. So like, if you start a VM, we need to just schedule it somewhere where we have capacity, and we may not be able to guarantee that, your VM can hit the same host every time. So that basically limits the effectiveness of hardware sealing.
But in this case, you could have you could implement some migration process where when you migrate, you would create kind of a exchange symmetric key, let's say diff-Hillman, and then you stop in one place and start in another place, and then use the new sealing key of the new host.
Okay.
Well, what do you do when you turn off a VM for a week and then turn it back on again?
Yeah, I wonder
Yes,
that was my next question.
That's a good question. So in this case, you would need some extra service like the provisioning service that you have there, which is the Azure Vault. So you would technically, that's difficult. I need time to think about a solution for this.
Yeah. I'll just keep going through questions in the chat, and then I'll come back to Usama here. Yes, SNP does provide sealing as far as I know. Do pre and post migrated VMs qualify as two VMs that you don't want to both have access to the same assets? I think pre and post migration, we treat it as the same VM with the same identity. So I think all the TPM state should just come along for the ride when we migrate. I think that was all that I saw in the chat. Usama?
Yeah, I a little bit different perspective from this one now. So this VM ultimately has to connect to, or even it may be relevant also for the secure key release, because a user will not have visibility on what's going on internally, like the provisioning phase and the secure key release phase.
Right.
And it's very much possible that the physical machine on which OpenHCL is running is not the same as where the Microsoft Azure attestation is running or where that cloud thingy is lying.
Right, yeah.
And I wonder what would be, or what exactly is the current status of the protocol. The SIG has done some work on attested TLS. So from that perspective, I was wondering if you have any information on the protocol which runs between OpenHCL and the cloud in provisioning, OpenHCL and secure key release phase, and OpenHCL and the user. Of course, the user thing will be dependent on the user, but the two things would be very Azure specific. I believe that would be pretty much set in stone, or at least something concrete, which is at least going on currently. So do you have any information on the protocol that is, or what kind of attested TLS protocol? I believe Microsoft had open, how was it called? Like the open enclave attested TLS, something like that, which was kind of pre-handshake attestation. I wonder if you have any information on that, or what is the current state of that?
Yeah, I do not. That's an interesting question, though. I'll have to see what I can find out there.
Can I answer a question with a question?
Please.
Sure.
For Sama, what is, I think I totally understand your question, which is, I've heard a bit about all these underlying protocols and the ways that the confidential VM gets bootstrapped and migrated, et cetera, et cetera. where can I get more details for an unstated reason? I'd like to make clear or understand what is behind this question. I can guess, but I actually want to hear from you. Like, why are you asking this question? What are you trying? What's the bigger picture? Why do you want to understand this?
Sure. So the reason of asking this question is that like the previous version of the protocol could not take care of, or the one that Microsoft previously used cannot take care of the runtime changes or the dynamicity of the VM. And from that perspective, I was very curious, let's say, to understand if there is any attested TLS protocol. As Greg, you would know that we have quite some projects in the SIG, like two of them working on intra handshake and post handshake and formally verifying them. And the whole motivation for that was that pre-handshake attestation is unable to take care of some of the situations which are required in such kind of VM-based trusted execution environments. Namely, the guest OS might have some changes, like you have Linux integrity measurement architecture, which protocols like Intel's RATLS and Open Enclave attested TLS was one variant of that with specific changes in that cannot take care of. So I was curious why when shifting from SGX to, let's say, VM-based Ds, which is now I'm seeing in this presentation like TDX and AMD SEV SNP. That was the kind of the background behind this question, to understand whether the protocols have correspondingly changed or are they still the same? Does that make more sense now?
Yeah, I think so. I think you're what I heard at a high level was you're thinking about some previous confidential compute offerings in Azure, like SGX enclaves. And these things were called confidential VMs, which can have either SEV SNP underpinnings or TDX underpinnings, ultimately with the virtual TPM in the confidential VM, as versus perhaps something which I don't know if you looked at, but like confidential containers in Azure. And what I think I heard was why and how did the protocols underneath shift? And if that's accurate, that's kind of that seems to be predicated on these things are kind of an evolution or closely tied. And I think based on my kind of experience and understanding, these are basically different offerings, kind of very they're independent different offerings based on different TE technologies, design patterns that offer different assurances, ultimately to customers that use them, to have different, scopes in terms of the TCB that must be out there and trusted to trust the code running in one of these things, et cetera. So if I understood it correctly, and Mike, feel free to jump in here if you interpret it differently or have different thoughts, but I think of those as very different, as independent kind of solutions that have different pros and cons for folks who want to run workloads in a confidential environment. So it's not like there's been an evolution of a service from A to B under the covers between like an SGX enclave running in Azure and a TDX CVM running in Azure. They're kind of independent, stacks of, generally independent stacks of code that have brought up both these, offerings.
Sure, I completely agree with you. They are from a implementation perspective, completely different things, but from a protocol perspective, all you need to communicate is just a piece of evidence. And I know several implementations which are still using a variant of like Intel's RATLS, which is an Open Enclave attested TLS, is the only one that I am aware of. Or is there something else?
So
maybe.
Are you asking essentially like if I create a attested TLS connection to last year it was an SGX enclave. This year it's a TDX CVM. Next year it's a confidential container in Azure. And you're asking questions like, okay, how do I know when the underlying environment has changed? So I need to like refresh my attestation for this TLS connection into that environment. Is that the question you're asking? Something like that?
Sure. So let me rephrase it. Maybe just by hinting at SGX, maybe I took it in the wrong direction. So what I'm trying to say is that from Microsoft, the only tested TLS protocol I am aware of is Open Enclave Attested TLS. And that doesn't work. That can work with SGX, but cannot work well with some of the cases of VM-based TVs. And I was wondering if there is now something else that I might have missed. We had several discussions in the SIG, nothing came up. So I'm still assuming it's using Open Enclave Attested TLS for all these remote communications to build a secure channel with the evidence.
And Mike, feel free to jump in. Or from my perspective, first, I think Mike and I are not involved in the Open Enclave Attested TLS, project, and quite frankly, I've not looked very closely at it very recently, so I can't say anything about how it can or can't be used, like in a confidential VM. I guess I'd leave it at there. I don't. Yeah. I'm not aware of if Microsoft has an all-up kind of like perspective on and recommendation on how it's best to do an attested TLS connection into each, to all the different confidential compute environments that they offer. I'm not aware of such a recommendation or opinion exists out there, and if it does, with how it relates to the Open Enclave attested TLS that you mentioned. Mike may know better than me.
I don't really. Thank you, Greg.
That's fine. I mean, I just wanted to ask if you have any opinion. Of course, like Microsoft is big, and I understand you work in a specific team. I will follow up on this because we are trying to standardize protocol in the IETF, and I was wondering from Microsoft perspective if that would be interesting, or Microsoft would be willing to, let's say, shift to a standard, because that would be good from.
I suspect that like this is just my guess based on what I know and what my best guess of what's happening is, I suspect at this point, everything's always a moving target and things change over time, but I suspect at this point that's not a problem that's actively being thought about and designed for, and that's an application layer problem. It's like, here's the environments, and go out there, and if you want to do a tested TLS connection into these environments, that's something that's out in that's for customers essentially to figure out at this point in time. That's my guess. I don't really know that's the truth.
I don't think that's correct, Greg. I mean, okay. The part, let's think about the OpenHCL and Microsoft Azure attestation. The customer or the user doesn't even know what's happening inside this process. And let's talk another example, like OpenHCL and the cloud. So the AK cert, how it's obtained, the user has nothing to do with that. So the third phase, the user will get a choice to use, let's say, which attested TLS protocol I use. So my question was more like these two phases. If the secure key release is on a different platform, if this cloud thingy is on a different platform, what protocol do they use to send over this evidence? Because the evidence is sent over in both. In one case, it gets over a token.
I think I can. So I think you're asking for the internal conversations between these components, where essentially attestation evidence is being passed between parties for verification. And presumably it's going over a TLS channel. Is it using pre, intro, or post? And
Yes.
how can you get more details on it? And I don't think we published the details at this point. And based on what I know, everything is post. It's an application layer kind of thing. It's all
sounds good.
Post the TLS connection being established. It's application layers doing the lifting, the heavy lifting.
Sounds good. We are also standardizing posts, so that would be a very good match. Thanks. If I can find some details, or if some details become available at future point in time, let us know. That would be very helpful.
Shalina has a hand raised. Or Shalini.
So I have a question on the interface that you are showing between VTPM and VMGS. When the VM is launched, right, and OpenHCL starts running, so it basically creates a EK and AK. That's what you mentioned. So EK and AK would stay resident in the CVM, right, until the VM crashes, right, like until that happens. And only in those scenarios where the CVM needs to be relaunched, is that the time when VTPM will go to VMGS to get the encrypted keys?
I mean, I'll just say they're persisted all the time. So when the keys are provisioned, they're persisted into the VMGS, and any VTPM operation that the guest OS does that changes any state in the TPM, that's persisted into the VMGS, and then that's of course loaded every time the VM boots.
So, basically, you are saying that besides the EK and the AK, also the PCR state is persisted in the VMGS?
Well, okay, so I guess PCR state is, I guess I think of that as like a runtime property of the TPM. So that's not persisted, but I mean, VTPM seeds, like the seeds for each hierarchy are persisted. Let's see, any persistent objects that are put in the TPM, NVRAM indexes that are persisted in the TPM, anything that's like persistent across TPM restart is persisted into the VMGS.
Okay, so I understand. The scenario is basically when the VM will lose its data, which is resident in the memory, and that will happen when the VM crashes. Then you can go back to VMGS and retain and basically get all the data back, right? Which includes AK, EK, and all the other persistent data.
Right. I mean, yeah, it's supposed to be just, analogous to a hardware TPM. So anything that a hardware TPM would persist into its non-volatile storage would be that's what we're using the VMGS for, essentially.
Okay, got it. Thanks.
Yep. Yep.
Well, looks like
I rather think we're out of time for my question. Maybe people could have a think about whether system or platform measurement is the right phrase, and we can talk about it on another occasion. That'd be great.
Can we have a choice of neither?
Come up with something else. That's fine.
What about
always have to...
in the SPIFFE architecture?
Sorry?
In the SPIFFE architecture, they have workloads and node. Is it something that we could adopt here too?
That's a possibility.
I would prefer
Hank has a view.
Sure, Hank, go ahead.
Yeah, just for your previous choice, that was platform and system. System is a very broad term, and in the TWI working group, we are distinguishing in broad strokes. I want to repeat this here. The platform is the hardware basis, the hosting OS, and then on top, the workload. So, and the relationship between workload and platform potentially not being reliant in any way on the hosting OS is important in the trusted workload identifier SIG. So I guess that's just a report from there. At the moment, you're using for the hardware capabilities for confidential compute the term platform.
So I think it might be worth my putting together a couple of pictures so that we can do this. I will give myself that task and send some stuff out to the group or the Slack or both, if I remember. How's that sound?
Sounds great.
Okay, I will do that then. Thank you very much indeed.
Thank you, Mike. So
Thanks,
I think we are out of time for today's discussion, or 1 minute left, and so I thank Mike Stoons for coming back again and subjecting himself to being peppered with questions. I appreciate it very much. Learned a lot. Thank you much, and I thank everybody for participating. I think there's a lot of learning going on today. So we're on again in 2 weeks. I think 2 weeks is Thomas will be chairing, and on the agenda is a Testa TLS yearly SIG project update from Ionut from ARM. So also sounds interesting.
Thank you, everyone.
Thank you.
Have a good couple weeks. Thanks all.